Hey team, it's Mr. Zimmerman, and today we're going to look at some equations. We're going to solve a variety of them, and I'm just going to kind of review some certain techniques in order to get you where you want to be. So let's go ahead and dive in, shall we? So looking at A, I notice how everything's on the left side is equal to 0. So the first thing I'm going to automatically do is factor. I'm going to go ahead and look at the numbers, the variables, and I see a factor of 2, and I see a overall term of x, or x to the first power. Now I'm going to go ahead and have to do the reverse of the distributive property and essentially divide the whole thing by 2x, leaving me with x squared minus 25. Now, right here, I immediately recognize that since it's a difference of two perfect squares, it is going to be a binomial. It's going to be a product of a binomial. So what does that mean? I know immediately what number times itself is 25? 5. It's going to include both negative 5 and adding 5. If you don't identify it right now, you really need to just start by practicing multiplying some binomials and noticing that when I multiply them, it is always going to produce something where it's x squared minus the perfect square. Notice how normally in quadratics, there's usually an x term. For these, when you multiply by the opposite, it does not produce one. So, continuing A, basically, I haven't really done anything yet. All I did was factor this guy out to make it into a form that I can handle. So now I'm going to go ahead and I'm going to solve it for when it's equal to 0. I'm going to get a total of 3 solutions. And when 2x is equal to 0, when x minus 5 is equal to 0, and when x plus 5 is equal to 0, resulting in the values below. I get 0, positive 5, and negative 5. Now, I'm going to go ahead and check. Do any of these numbers make it invalid? There's no fractions. There's no radicals. So x can equal 0 and plus or minus 5. I'm going to go ahead and look at B right now, and I see that it's going to have 2 of these guys where it's the difference of 2 perfect squares. When I see this, it's automatically going to be what number times itself is 49? Well, that's going to be 7. So I'm going to get x minus 7 and x plus 7. Looking at x squared minus 9, that is going to factor out to be x minus 3, x plus 3 equals 0. So I rewrote this equation with an equivalent equation. Now this is going to give me the values. If I were to solve this, I can get 4 cases. And these 4 cases are going to be when x is equal to plus or minus 7 or plus or minus 3. And I get that from the appropriate colored region.